Hello students, this is another lecture on reciprocating pump. In this lecture we will discuss about separation in reciprocating pump. Okay. First of all, what is separation? When the vacuum pressure or pressure head inside the cylinder reaches the vapor pressure of the liquid, then the continuity of flow will stop and separation takes place. See, for water, the vapor pressure is minus 7.8 meters or 2.5 meters in absolute scale. So when this pressure reaches, then the water starts boiling and vapor bubbles are formed. So ultimately it leads to separation in the machine. Now, where these things happen? This phenomenon occurs in suction and delivery pipes of reciprocating pumps. In suction, the separation occurs at the beginning of suction stroke. That is, this is the minimum pressure head at the suction line. So the possibility of separation is more at the beginning of suction stroke than the end of the suction stroke. Similarly, in delivery stroke, the possibility of separation is more in the end of the delivery stroke because at the start of the delivery stroke, the pressure will be more than the pressure head at the end of the delivery stroke. So we cannot operate a pump beyond a certain speed, which will create separation. So in this lecture, we will discuss how to find the maximum speed of a reciprocating pump. So I already told you the possibility of separation occurs at the beginning of the suction stroke. So we have to ensure that at the beginning of suction stroke, the pressure head should be greater than or equal to the separation pressure. So if you know the separation pressure of the flowing fluid, you can decide what would be the suction pressure at the beginning of the stroke. Now, at the beginning of suction stroke, the absolute pressure head, we already discussed this in our first or second class. The absolute pressure at the beginning of suction stroke is pressure head, atmospheric pressure head minus suction head plus acceleration head at the suction pipe. And this is the absolute pressure head at the beginning of suction stroke, and this pressure head must be equal to separation pressure head in absolute scale. Okay. Now this is the beginning of suction stroke. The pressure head at this point A dash is atmospheric pressure head H atmospheric minus this is suction head HS minus this is acceleration head HAS. So the absolute pressure head at the beginning of suction stroke is H atmospheric minus the sum of HS plus HAS. Now during delivery stroke, the absolute pressure head at the end of the delivery stroke, I told you the possibility of separation occurs at the end of the delivery stroke. So at the end of the delivery stroke, the absolute pressure head is H atmospheric plus the sum of delivery head uh, plus sum of delivery head and acceleration head at the delivery pipe. So this uh, pressure head should be equal to H separation in order to avoid separation. So this is uh, the end of the delivery stroke. Uh, you may have some doubts about this point, because how this separation happens if this point is above the atmospheric pressure line. Okay, this point may not be uh, at the at above the atmospheric level. It sometimes it may uh, reach here or here, depending on the value of acceleration head at the delivery pipe. So it is possible to have separation at the end of delivery stroke also. So in order to avoid separation at the delivery, we have to ensure that H atmospheric plus HD plus HAD is equal to separation pressure head. See, remember that these are in absolute scale. All things are in absolute scale. Okay. Now, how to find the speed of the reciprocating pump to avoid separation? See, uh, this HAS and HAD are the acceleration heads. These term consists of omega, that is angular velocity uh, of the crank. Then if you know omega, you can calculate n also, because omega is equal to 2 pi n by 60. So n is the speed of the crank in RPM. So if you uh, find the
if if you want to find the uh, maximum speed of a reciprocating pump, you first of all you have to equate these two terms and then substitute the uh, HAS or HAD in terms of omega, then find omega, and then finally determine the speed n. Now we are going to do an example, a problem on this. The problem says the diameter and stroke length of a single acting reciprocating pump are 50 millimeter and 100 millimeter respectively. It takes the supply of water from a sump of 4 meter below the pump through a pipe 6 meter long and 30 millimeter in diameter. It delivers water to a tank 15 meter above the pump through a pipe 40 millimeter diameter and 20 meter long. If separation occurs 70 kN per meter square below the atmospheric pressure, find the maximum speed at which pump may be operated without separation. Assume that the piston has a simple harmonic motion. So this is the problem we are going to solve. See, the given data are we have given piston diameter D, capital D, 0.05 meters, stroke length capital L, which is 100 millimeter, 0.1 meter, crank radius, it is the uh, uh, half of the stroke length, then 0.05 meters, suction head given 4 meters, and suction pipe length is also given, it's 6 meter, suction pipe diameter 0.03 meters, delivery head 15 meter, delivery pipe length 20 meter, and delivery pipe diameter is also given. It is 40 millimeter or 0.04 meters. Separation pressure is given, which is 70 kilonewton per meter square. See here, they give they we have given the separation pressure, not the pressure head. Separation pressure head, it is 70 kilonewton per meter square. So we have to convert this separation pressure into separation pressure head. So to convert this, uh, how do we calculate pressure heads? Divide by rho into g. So if you want to convert a pressure into pressure head, divide that pressure with the rho g. So H separation is equal to P separation by rho g, which is equal to 7.135 meters. It is in gauge pressure, that is also noted. Minus sign is the separation pressure head is always negative because it is always below the atmospheric pressure. So if you take atmospheric pressure as your 0, then it will be minus, from 0 it is negative 7.135 meters. Now we have to find the maximum speed of the pump without separation during suction and during delivery stroke, and then we will select the least speed among these two values. Okay, otherwise it will not work properly. So the condition is already we have discussed. uh, H atmospheric minus Hs plus HAS is equal to H separated, separation pressure. All are in absolute. So see, H separation absolute, how do you find the absolute value? Absolute value, if you want to find absolute value, absolute pressure value, you have to add atmospheric pressure to that value. So H separation absolute is equal to H atmospheric plus H separate. So if you substitute this expression in equation 1, you will get minus Hs plus HAS is equal to H separate, and substitute the value of HAS as Ls by G A by AS omega square R is equal to 7.135, minus minus cancels, 7.135 meters. Now we will get the value of omega. Now from omega you will get speed during suction is 58 rpm. Similarly, if you consider the delivery stroke, then the separation occurs at the end of the delivery stroke. The end of the delivery stroke, the acceleration head or retardation head is theta is 180 degree. So cos theta is equal to minus 1. So it will be negative. So see, H separation is again H atmosphere plus H separation. Substitute, if you substitute this, you will get HD plus HAD is equal to H separate. Okay. See here HAD is negative because theta is 180 degree. So we will get HD minus HAD is equal to H separated, that is 15 minus the equation for HAD is equal to minus 7.135 meters. Now substitute this value, you will get delivery speed is 112.5 rpm. So we have two speeds. So if you run the pump in this speed, it will fail during the suction stroke. Okay, so you have to run the pump in the least speed, uh, that is 58 rpm. So by this, I think all uh, important portions of reciprocating pump has covered. The rest of the portions are assignment topics. So write your assignments, draw the figures neatly, and submit when we class starts. Okay. Thank you.